Welcome to this ninth railway talk. Today the topic is solutions for switches. My name is Marco Corradini. I am of CIFI, the Italian Railway Engineers Association. This is part of the Union of European Railway Engineer Association. And today we have two presentations. The first one is of Rob Taylor from Interflon, UK, and he will present us improving asset reliability and asset life. And the second one comes from Austria and is Robert Kollock, and he is from Austrorol, and he will show us switch point rollers more that rolling instead of sliding. So we will hear these two presentations, and I remember that at the end we will answer at all the questions that you will have. We hope that we'll find this talk very interesting. Please write your question in the chat, or at the end you can raise your hand using the functionality of Teams. So I think that I've said all the main information. I hope that you will find this talk interesting. I remember that by railways, switches are very crucial and very important element. So we have to take care of this element. And said this, I give the floor to Rob Taylor that will start with his presentation. Thank you very much.
Thank you, Marco. Okay, so as Marco introduced me, I'm Rob Taylor from Interflon. Interflon is a Dutch company that supplies products into the railways around the world. So I'll just go through my presentation now. So using traditional based lubricants on switches and crossings, this is traditionally what you would see out in track. The typical grease stroke lubrication that's out in the domain of the railways. Interflon is a new technology which is a dry film coating, and originally this product was brought in to help with better visual inspections, better weather resistance, but also to help improve asset reliability. So clearly at the bottom you can see the difference between the two different products. The product at the top is dirty and hard to look at any track inspection stuff, and the thing on the bottom is the Interflon dry film coating, which is easy and transparent. A little bit about the technology. Hopefully you can hear this.
Have you ever realized that if you always do what you've always done, you'll always get what you've always got? This is the Interflon story. A story about the need to innovate. 3500 BC, humanity came up with a brilliant idea, the wheel. An invention that would change the world by making a centered hole in a cylinder and adding an axle. The wheel enabled heavy transport, but its use also meant friction. So after 1500 years, we added spokes, but this didn't eliminate friction. And when the wheel evolved to gear complex machinery, meant even more friction. Even the discovery of lubricant didn't fully solve it, because the fluid didn't stick to the metal surface, still resulting in wear and ultimately breakdown. Then in the year 1980, Wim Horsmans came up with a visionary idea. He created micronized particles that fill up the microscopic notches in metal. By polarizing these particles, they stick to the surface, leaving an impenetrable film layer over grinding parts. He called this unique technology MICPOL. MICPOL significantly reduces wear, lubricant usage, and significantly reduces CO2 emissions. His invention became a vision, named Interflon. A vision reframing technical maintenance all over the world, making any machine a better machine. Embrace innovation to benefit tomorrow. Interflon.
So Interflon is a very different type of technology. So first of all, we developed this technology in-house by micronizing and polarizing solid particles. And it's the solid particles that form the dry film layer. Also, at the same time, we've also improved our technology by polarizing some of the carrier base oil. By doing that, we can actually penetrate deeper into the pores of the surface, and we form a bonding bridge between the solid and the rest of the lubricant. It helps prevent metal-to-metal contact and what we call stick slip. So this initiates startup friction. It also repels weather, protecting against corrosion, but also things like ice as well, ice adhesion. It reduces friction to a minimum, but also a constant. So it's a long-lasting, low friction coating. So a bit of a story as to the process so far with Network Rail. So the product was originally developed for the German railways back in 2000. And as you can see there, the scope was to come up with a weather transparent product that would improve performance and reduce failure. Network Rail actually found Interflon back in 2008 after a £9 billion upgrade on the prestigious West Coast Main Line. And they had constant problems with new installations of S&C that were constantly failing. The testing of this new technology was done by Network Rail's own engineers, and it was tested on several poor performing assets to see whether there was any benefits. After 2 years of testing on the network, basically the product was given a full and final acceptance. It also proved itself to be a very good product to prevent further failures whilst also improving the mean time between failure. And a couple of cases here with graphs on the right. So the top right graph shows the failures that the assets were having prior to using Interflon. But as you can see, there is a flat line on the top one, second, third, fourth, and fifth. The flat line was when Interflon coating was actually introduced onto these failing assets. The bottom graph shows the high-speed switches called high drives. So these were installed at this period, and those represented these failures. So as you can see here, the more of these high-speed switches that were introduced into mainline, the failure went up to here. Interflon coating was applied on a few point ends, and you can start to see the failures start to come down. But what is really impressive is the more ends that are coated with the Interflon technology, the repeat failures come almost down to zero. The most critical part of any switch to lubricate or to have low friction is actually the heel section, which is the bit of rail at the back from the fixed position. If the first meter sticks through corrosion buildup or stiction, then you need more energy from the motor, normally connected to the front of the switch, to throw the switch across. And as you can see here with the curve, you've got the reference, which is the pink, see the flexure, and then after the first meter sticks, you can see the difference in the actual flexure curve itself. Problems arising around roller layouts that we found here in the UK are that you've actually got the switch when it falls back off the roller, back onto the slide chair. It's still got between 3 and 4 mil of travel before it fits up to the stop rail. And also at the heel section, the bit that I've mentioned that you can't ordinarily get a roller, you actually get what they call force down. So this is where you've lifted the switch up and you can see the amount of pressure on the back end of the actual switch itself. This is typically showing you problems on high-speed switches where you get this force down at the back of the switch. You could probably see on the photograph here the gap that actually should be closed. Likewise, you can see it here, see the indentation there. And this particular switch was on the West Coast main line, and it had 477 repeat failures in 21 weeks. When the Interflon coating was applied by Network Rail's engineers, they had 0 failures over a 24-week period. They also noticed there was a huge reduction on the amount of power needed to throw the switch, because you've now got low friction throughout the whole switch. And they also got engagement with the switch at the back end of the switch, where you've got the heel blocks. They also increased the freewheel clearance, so there was no flange back contact at the back of the switch from the train flange. This again is a document that was put together by Network Rail on high-speed switches, and basically you can see the distance blocks here. You can see the gap there. It was a 7mm gap. It's been renowned to be up to almost 20mm gap at the back of switches. Now it's actually holding off, so there's clearly a problem at the back end of the switch. So issues with force down. So as not only are you not meeting the blocks at the back of the switch, but when the train actually comes through and it pushes gauge, you can actually get this sort of thing here happening. So this is where the actual switch insert is actually being pushed through the back of the cast plate. You can see it's burst the cast plate here. You can also see high friction points here. These pins are being broken out and burst through the fact that the train is coming through the switch and it's pushing gauge. And again, that's down to heavy force down at the back end of the switch. So some of the testing data that come back from Network Rail along the way. So this is typically one of the high-speed switches, and they have RCM, remote condition monitoring, fitted to most of the switches. And if none of you have seen an RCM graph before, I'm sure some of you have, what you have is you have the inrush of electric power to physically then start to move the switch, and then you've got the transit time before you get a lock up and a fit up, and then the motor dies. So that is your typical reference point on a high-speed switch, the green reference. The brown is the conversion, and the blue is once it's converted and the coating is cured. And as we mentioned earlier, you actually see a reduction in throw forces. On this occasion, it's 30%. We've actually seen as high as 52%. These are the service affected failures. So this is when the train doesn't arrive on time. You can see here in the graph, you can see without Interflon coating, you can see the failures of switches that aren't coated and the failures of ones that are coated. And you can clearly see there that with Interflon, they're much more reliable. But what was quite interesting was these two humps here, where you started picking failure back up. When Network Rail asked the question to the areas that had these failures, the question was asked as to why the failures had come back. What had they done different? In actual fact, they'd actually run out of product to put onto the side chairs. So it clearly shows you that when you don't apply the product, the failures do come back. This is the chart showing the mean time between failure. So this is when the switch is going to fail. You can see where it was prior to Interflon, which is the blue line. And then you can see the reference up here. So the mean time between failure vastly increased. Again, showing that the coating works. This was the national high drive data that came back from Head of Engineering. And you can clearly see when the Interflon product was applied. And you can also see that they're expecting the failures to come down to almost zero. This is one area of Network Rail that did an in-depth transition over to Interflon products. And as you can see here, there was some financial savings of £1.3 million saved in switch failures, 627 less point failures, which reduced point failures by 80%. So again, clearly referencing the use of Interflon and the fact that it reduced reoccurring failures. SWIAG were also involved on doing some bench testing for Network Rail, and the two graphs here, one on the left shows you a standard molybdenum plate, which is an ultra low friction coating, and it shows you the reference point of friction when it first starts to move, and as the switch starts to move back and forth, cycle back and forth, you can actually see that the friction increases, 5,000 movements, 10,000 movements, and then it goes straight off here. And then at 20,000 movements, the actual friction increases to the state where you would need to do intervention. The Interflon product was also applied on top of the SBB plate. And as you can see here, you go past 10,000 up to 20,000 and constant friction coefficient up to 70,000. And what came from the testing was, first of all, the longevity of the coating, also the constant friction coefficient of the coating, so almost a straight line, but also as well, they referenced the two friction forces. So here's a plate with no lubrication, constantly gets worse with friction. With the Interflon, it's much lower and it's a constant. So two graphs here, one of a roller. So this shows you where the friction of the rail is 0, and then obviously it has to get up onto the roller. Okay, that's where the humps are. Okay, and then again you've got the same thing with Interflon on a slide chair without rollers. And just to give a comparison, the coating is as low friction as a roller. So again, that's data from SBB. From a longevity point of view, this is the reference of how long will the coating last. You can clearly see here in the number of days, we can actually get up to 13 weeks between coatings, depending on the amount of switch movements, the load, and also the condition of the switch as well. On some of the crash tests that Network Rail did, they actually got 25 weeks before the switch started to fail. At the moment, Network Rail run 3 different periods of reapplication, 4 weekly, 8 weekly, and 13 weekly, again, depending on condition of the switch and number of movements, etc., and whether they contain rollers. Also, with the coating, you can actually build up the layers of low friction product. So clearly you can see here again, this is the RCM, so remote condition monitoring, and you can see the first coating, and you can see a second application on top of the first coating, and you can see that it vastly reduces the friction forces, but again also the throw time as well. Network Rail, after doing all the testing around the network, put together reliability improvement alert, which went national to all the maintenance engineers in the routes to say this is now the product that you would need to use to improve performance. A booklet was also put together, which has got every process of the conversion of Interflon into slide chairs, fish plates, overhead line equipment, signaling equipment, etc. And that booklet's been put together by Network Rail and Interflon that we use for training. There's some testing done in other railways, but also on other equipment. So we do a lot of stuff for the offshore industry. So we've actually tested the coatings down to minus 195 C using cryogenics. This product can also be applied below minus 30 C. It's water resistant. It is also heavier than water, denser than water. So rainwater will not wash off the application of the product. Also, if you've got areas where there's no point heaters, it's also important to know that the product will resist ice adhesion. It's hydrophobic. And again, talking about hydrophobic and ice adhesion, this is some of the testing that was done by IAD, which is the high-speed switch applications for what we call high drives that are used in the UK. And these rods would freeze with water or ice, and they would get stuck between this nylon block. So testing was done by IAD, and before using the Interflon coating, they had 150 Newton meters of force to be able to throw the switch. And after applying the coating in the same conditions, they reduced that down to 70. Again, there was a reliability instruction alert put out due to rollers that had started to fail out in track. Rollers are a really good product. They really do work well, but after a period of time where there is contamination, high loads, voiding, things like that, you then start to pick up problems with these particular rollers here in the UK. And a reliability instruction alert was put out to all the route to say that Interflon Finlube TF had been trialled and tested along with other products, and Finlube TF could actually improve the performance of rollers when they started to seize or get stuck. London Underground also use the products. They use them on their air points, mechanical points, and again, they've been able to reduce their forces by 50%. And particularly like Network Rail are doing currently, they're actually sweating the assets, so they're making the assets more reliable. This is where the coatings are being used even more. And again, in some of the mechanical machines, products are now being used by Network Rail because, as you can see here with the graph, the RCM, you can see the reference point here and here, and you can see the improvement having used our product in the machines. This is another application that Interflon have been involved with Network Rail. So this is where you get the switchblade damage when the train starts to hunt and come through the switch. You can then start to get breakout on the switchblade. Typically, grease is used to try and reduce the friction on the switchblade, and it does quite a good job, but unfortunately, it doesn't completely stop it. But also, when you come to inspect, the black grease can actually fill in these breakout defects, and it's very hard then to spot and check for these issues. And of course, that is a potential derailment risk for any train going over a set of S&C. Interflon OG grease was tested amongst other products, and it is physically a dry coating that goes onto the blade. In fact, the second photograph down here, you can actually see the coating on, and it is completely transparent. So again, when they go and do track inspections, they can see any breakouts, but also, believe it or not, it can actually reduce the damage on a switchblade. And to give you an idea, so this is the weld repairs information coming back from Network Rail, where they've had a lot of heavy freight. So there's a lot of lateral loads coming through the switches, and you can see prior to using the coating, they had 300 weld repairs, started to use the product on a few point ends, and as you can see, the weld repairs have come all the way down to 13. And again, you can see similar switches, and you can see the weld repairs have dropped down to 0. That's just by putting the product onto the switch. So, Interflon was asked whether they could help in designing with Network Rail an automatic applicator to apply the slide shear lubricant. So this product was actually developed, designed 8 years ago and put into track, and it had a very successful trial on the main line. It was a signature away from getting full approval when Network Rail lost its impetus of what they wanted to bring an automatic lubrication system out for, and it got parked in the long grass. Unfortunately, there was an accident a few years ago where sadly 2 people lost their lives, and Network Rail asked us to bring this out of the long grass and to look at upgrading it to anything that's been sort of brought out from a technology point of view, AI, things like that. So the system's actually been developed to apply our product automatically without people being out in track. Sorry, 1 second. For whatever reason, my screen's frozen. There we go. So this is the information coming back from the background of the trial. So the product, as I say, was tested back in Western. It was tested on NR60, so high-speed switches, 125 mile-an-hour trains, and also heavy freight trains. Some of the upgrades are now using Wall-Raven clips instead of magnets. Also, switch position detection to apply lubricant when the switches move, remote monitoring and pressure levels, power and lubricant levels. Again, control units can deliver up to 32 slides, so it can be used for high-speed switches. Improvement to tampability being explored by moving nozzles from tamping zones. There's some tests that are being done at the moment, and there's also trials for different parts of the network as well. Can be solar powered, so the battery has quite a long life battery. It's quite a unique battery that's been developed for it as well, but it will have it'll have solar trickle. And the life of the battery is around about 6 months to 8 months without the need of trickle charge. But again, all the information is there. Remote condition monitoring as well. It will also talk to the intelligent infrastructure system within Network Rail. So this is something that's being planned for to be trialed this year. There's obviously schematic layouts. It can do a whole switch length, or indeed it can do the heel section of a switch. So depends which you decide, whether you want heel or you want the full layout. But this is intended to be used in very busy sections, hard to get in areas, and this is part of the development at the moment. And again, there's some intelligence in there that will tell the system when to move, how to move, when to lubricate, etc. Okay. Hopefully that's okay and people have received that okay. Thank you. I'll pass over now to Robert.
Okay, thank you very much. I'm sorry. Good afternoon, ladies and gentlemen. Unfortunately, I've lost my voice 2 hours ago and I was not able to find it again. I hope you can hear me. Thank you very much for joining us this afternoon. My name is Robert Koloch and I'm representing Wieland Austria. And Wieland Austria is the owner of the trademark Austrol switch point rulers. First of all, I want to give you, first of all, I want to give you a brief overview. Who is the Wieland company? Who is our backbone? And my goal was to give you an overview about roller systems in general, and not only to make a marketing presentation. And the goal was to show you different solutions. And of course, I will go into more detail with our roller, the Austrol switch point ruler. Yes, and then you see the different points in the next 20 minutes. And let's start with a brief overview about the Wieland Group. The Wieland Group is an international, a well-known player in the copper and copper alloy field, with production sites all over the world. And we are based in Austria, near Vienna, and we are a little bit different to all other products in our group. And because we are the only plant dealing with railway products. Here you see the main figures of our group. It's a very strong backbone, but on the other side, we are a small team, very flexible, and we are going to solve individual problems for our clients and potential customers. As mentioned, there are 2 plants in Austria, one in Amstetten, and we are based in the Enzersfeld plant. We have different departments, and one of these is the railroad department with its main product, the Austrol switch point ruler. As I said, I want to give you a brief overview about the different stages and developments in this field. A long time ago, they started to try to insert rollers into railway switch points, but there was no real success with that. And of course, a lot of tests with different coatings and sliding inserts and all of this stuff. And in the the 1980s, a locomotive operator, locomotive driver of ÖBB had the great idea to develop more or less, you see here the roller, the first Austro switch point roller. And the idea at that time was to insert the roller into the space between the sleepers and not to integrate it into the slide chair. In the meantime, yes, a lot of different products are on the market, and it took a long time that switch point rollers became the standard. And there was a question also in the chat. I would say in the meantime, so far I know, a lot of main and well-known operators in Europe equip new turnouts with switch point rollers already right from the beginning. Rob told you something about Interflon, and it's maybe a little bit strange to hear now something from the roller side. We are approaching to this topic from different sides. Here you see some pictures, very old style with a massive contamination of the ballast, very inefficient and expensive, dangerous, and all of this lead to an enormous amount of lubricants which are needed to lubricate a turnout a year. I know Interflon is different, but I'm talking about the general idea of lubricating. Up to 30 liters of lubricants every year, every single turnout. How can you divide the roller systems on the market? And I tried to make different columns to show you that. You can integrate a roller into the slide chair, you can integrate it close to the side chair beside it, or you can integrate a roller between the sleepers. We also say in the sleeper bay. There are also different solutions how you can fasten it to the switch plate. You can directly fasten it to the stock rail. You can fasten it on the sleeper with brackets, or together with the at the switch plate directly. And very interesting and very relevant is this system, the roller system. Rigid, is it stiff or is it flexible? And that's the reason what I mentioned, that I cannot go into detail of other systems. I'm not allowed to, and I don't want to talk about our about the other systems on the market. I just go into detail about Austral, which is between the sleepers, which is fixed with special brackets, and which is permanent elastic. It's a main difference to all other systems. We are using steel springs, and it's elastic all over the lifetime. Here you see a high-speed turnout, very long radius, 6,000 on the radar system, on slab track, special fixation 300 V in Germany. Here you see the positioning between the sleepers on the slab track, and here you see the steel springs left and right, a large roller diameter, and you also see we have different possibilities to adapt the roller in the head. And now a short video to give you a brief feeling how it works. This is the tip of the switchblade. And here you see the switchblade when it's operated, it immediately rolls onto the roller. There's no gap. There's a permanent contact between the roller and the switchblade. The switchblade is lifted by the roller. You can adjust that by 1 to 3 millimeters. That's our recommendation. You can do more, but that's not necessary. And here you see a system for retrofitting into existing turnouts and a massive decrease of throwing forces after the installation of our switch point rollers. I mean, it's clear if a turnout is well lubricated, normally you have very low throwing forces, operation forces. But how long is it well lubricated? That's the question. And our goal is to guarantee this low throwing forces all over the lifetime, 24/7, and without any maintenance, without any dangerous lubrication intervals. Sorry. Once again, how it works. Here you see the switch, the stock rail, and the stock rail, the switchblade, the roller in the sleeper bay. And when the switchblade is operated, there's no gap. The switchblade is immediately lifted onto the roller and rolls into its open position with a minimum of friction, and it rests there till it's operated again into the other direction. I also said we have elastic padding, we have the elastic system. This is due to these two steel springs left and right. With this solution, we can guarantee flexibility over the whole lifetime. Very important is also that by the pre-tension of the system, because the roller is installed and then we make a pre-tension to guarantee the contact between the roller and the switchblade. You have also a horizontal force component which presses the switchblade firmly to the stock rail, and so there are no gaps between the switchblade and the stock rail. On the other side, we also bring the switch blade into the correct position, so you have a correct passage or narrowest passage between blade and stock rail. Why do we insert our roller in the sleeper bay between the two slide chairs? A reason is not only using this steel springs. A further reason is we want to guarantee a smooth operation. And for this, we have a very large roller diameter, which with a special design, 2 roller bearings, 2 shaft seals, and 2 cover discs. And so we get a hermetic sealed system. No fluids, no contamination can go into the roller and block it after a while. So it's a 3-time or 3-level sealing, and even during grinding or such operations, it's not necessary to cover the roller. The roller will work from -40 to +80 degrees. And here you see also 2 adjustment screws to make the vertical adjustment to make the pre-tension in the system. An argument, if you have a roller in the middle of between 2 sleepers, it's a problem with the tamping. We have certificates from Plaza and Teura and other railroad operators that the rollers remain in track during the tamping procedure. There's no, the tamping process, the tamping quality is guaranteed also with installed rollers. Furthermore, one side is covered by the open switch blade, and here it's only 70 millimeters away from the switch blade, and the tamping operator, if it sometimes has to adapt the tamping pick a little bit, and then he moves on, and that's confirmed it is not a problem with installed rollers in the sleeper bay. And very important is you don't have to cover them for the tamping procedure. You don't have to use any cover sheets or anything like this. They can remain there without any special protection. Also during milling, during grinding, during welding, they stay there. As I said, a well lubricated turnout is working very smooth, but we have also cases where we reduced the throwing forces dramatically, and it's not a fake done by our controlling department. It's a real graph what we showed to you here, and that was the throwing forces before, and this was after the installation of Austrol. Here you see also the curve before, different systems, throwing forces, and that's the currency, also lower. And it shows that we guarantee low throwing forces, and that's good for the point machine. We protect the point machine, and the most important thing is to increase the track availability. Less delays, less troubles with the turnouts lead to a higher track availability, and finally to a higher customer satisfaction. Not only the customer directly, the railway or the maintenance or the railway operator, but also the person in the trains reaching their final destination on time. That's the most important thing. We have different solutions, and we adapt our mountings to the needs of our clients. Here you see something for direct fixation on timber sleepers. You can use it also on plastic sleepers. Sorry for using that word. But also here for the retrofitting on concrete sleepers, special design for PWG turnouts, and here for new turnouts, for the pre-assembling in the turnout company, in the turnout factory, we use plates, and with this connecting rod, we guarantee the distance between the sleepers, so there is no movement between the sleepers possible, and this can be installed already in the factory together with the full turnout. What we also offer now is a solution for movable frogs. This lead to a completely lubrication-free turnout from the tip to the movable frog to the swing nose crossing. And we're using a special lever and combining this yoke with the quality of our standard rollers or flexibility. And there's a ramp, and when the movable frog is operated, it is lifted by this ramp, and then it's going back down and rests on the slide chair. That's also, in any case, that's very essential to know. The train, the switch plate, when a train is passing over the switch plate, is always resting on the slide chair. It's not lifted by our rollers. That's impossible. I just want to mention that. Always resting on the slide chairs during the train is passing. This is a very successful system for movable frogs. We have equipped the whole network in Netherlands with that at ProRail, and a lot of turnouts also at Deutsche Bahn in Germany. And in the meantime, several hundreds of these movable frogs are equipped with our system. Also here, the reduction, you see the red line, a reduction of the throwing forces. Here, the situation before, and this is the situation after the installation of Austral HSR. So that leads me to more or less to the end of my presentation. What I want to mention is, again, the permanent contact of Austral with the base of the switch tongue. The flexibility in adjusting vertical and horizontal, and using steel springs, it's unique. When the switch plate is operated, the immediately lifting of the switch plate, there's no gap between the roller and the switch plate. The very simple retrofitting into existing turnouts. And on the other side, if necessary, pre-assembled solution for new turnouts with very short installation time. And an extremely long service life, 5 years warranty, but we expect more. You can expect more of our rollers. A solution for the switch tongue, but also for the movable frog, and a system where we can adapt our mountings to the needs of our clients. And maybe I didn't mention that. In the meantime, there are all over the world more of 250,000 of these Austral switch point rollers in use. This brings me, or leads me to the end of my presentation. Thank you very much for your time. So if there are any questions, please feel free.
Thank you very much, Rob and Robert, for your deep insight in this very interesting topics. That is very important for us as infrastructure manager. I didn't say it, but I work for Swiss Federal Railways, so in the infrastructure maintenance, and switches are a very important element in the railway network. I also appreciated a lot, Robert, your effort in doing this presentation with a voice problem, but this is very good from you that you did this presentation. So I want to underline another point that you said, Robert, that the customer are not the infrastructure manager. So we are not the customer, but I want to remember the customer is the passenger or the freight trains that has to come on time at the destination. And if they are happy with our service, then they come again. So this is the important customer that all we as railway men and railway women have. Okay, so that said this, I look at the questions that in the meantime were put on the chat. There are also questions on the Q&A. I start with the chat. Siegfried Krause, our German colleague of the VDI, make a suggestion. I've seen that you have answered, Rob, that will be also not in Münster, but you will be in Berlin at Innotrans.
Yes.
So thank you very much, Siegfried, for the suggestion, and I greet you. I go to the next question from Lasse Hansen. What is the proportion of roller in comparison to plate switches in European networks? So for example, UK, Germany, and etc. You have just given an answer, Robert. If you want Rob to comment these questions.
It's really hard for me to say that. Unfortunately, the clients don't want to always forward all this information to a supplier. So far, I know I can only speak for the markets we are involved. New turnouts normally are equipped with a roller system right from the beginning, but it makes sense to install rollers. Excuse me, Rob, maybe also to use your system for turnouts, which I expected to stay or to lay there for a longer time. I understand that nobody will install rollers. Even the investment in comparison to the full amount of full price of a turnout, it's rather low. It's about 2% of the full investment is the part of the rollers, 2 to 3%. But I understand clients, they say, if there is a rest time of, I don't know, a couple of years, I don't insert rollers, and then I take it out in 2 years, they all turn out. So there is a retrofitting market, depending on the client. In detail, I cannot give you an answer about the share. I would say, from my point of view, 100% rollers in new turnouts. I'm not sure if that's true, but there are still thousands of switch points which have no roller system or have no good lubrication system.
Okay.
Sorry.
Thank you very much, Robert. Then I go to a consideration that it's very interesting from Steve Fitzstone. I read it because it's I find it very nice. I used to be National Maintenance Director for Network Rail, responsible for all of the British Railway. I had a major problem with switch rollers that were unreliable. This had two effects. The switches were unreliable, which caused disruption to passenger and freight services. It was also costing a lot to purchase new rollers to replace the ones which were sized. The rollers were supposed not to require any lubrication once they were installed. My reliability team started to use Interflon Lube TF to lubricate the rollers. The reliability of the rollers improved significantly, and the requirements for spare rollers almost disappeared. My team issued a national instruction that all rollers should be lubricated using Interflon Lube TF. So the conclusion is, in my view, rollers are an important part of the switch system. However, if they are not lubricated, they will be unreliable and expensive to maintain. Maybe the two presenters should collaborate, accepting that highly reliable rollers should be lubricated with Interflon Lube TF. I think that is we have seen two different systems, but probably the combination of the two solution that we have presented is maybe the better that we can achieve. I don't know if you want to comment this, Rob and Robert.
So from my point of view, you know, I've been in engineering 25 years. My previous role before rail was the mining industry. They tried to use a lot of sealed for life bearings and things like that, which are really good. But unfortunately, when they fail, they're catastrophic failures. With Network Rail, they were having lots of failures on their particular rollers, which weren't the Oster roll. So, you know, there's no such thing as a fit and forget or maintenance-free system when you've got metal rubbing on metal. So for me, always a small bit of lubrication to help, in my opinion, is the best solution. So I've worked with SWIHAG on a number of different layouts, both in Taiwan, China, and here, helping improve the performance of layouts fitted with rollers. So for me, it's a hand in glove type of relationship.
Thank you very much, Rob. You want to add something, Robert?
I'm thinking about what I should say now. Maybe we should talk about the idea of Mr. Featherstone. Two high quality products to combine. Maybe that's a real game changer. Because in this case, he mentioned we were not involved. I think there are no tests between Austral and the combination with Interflon. Maybe they are really completely different. And maybe that's but I think it's too early and we will think about it, right, Rob? We will talk about it.
Yeah.
Okay, thank you very much for your reply. Then I go to the Q&A because I've seen that there are also here some comments. Sander Kev asks, what was Interflon also try on double junctions?
So scissors and swing nose crossings. So yeah, they've been used on lots of different junctions, both here in the UK, but also China, Taiwan, as I mentioned, also SNCF as well. So yeah, it's been used on different combinations of different junctions and different switch types.
Okay, thank you very much, Rob. Then he asks again, Interflon is to be used now on all National Rail 60 MKI and MKI 1-2 switches or some selected switches depending on EMG TPA traffic. Is it sprayed only on slide shares?
So Lube EP is sprayed on the or applied onto the slide shares. It's literally a teaspoon, 4 mil. That product goes onto each slide share. With regard to Lube EP itself, it can be applied to a number of different things other than slide shares. I think I put my rail manual in there to have a look at. But with regard to the switch blades, then that's a product called Grease OG, and they're the two main products that we use on turnouts.
Okay, thank you very much. I don't see any more question. I have a question. I do the first one to you, Rob, because this interests me as an infrastructure manager. You didn't go so in depth, but I do these questions. Can the application on switches be automated?
Automated.
Automated.
Yep, it can. So with regard to, when you say switches, are you on about slide chairs or the blade?
Switches.
Okay, so the slide chairs, the chairs, yeah. So that's what we're looking at the moment with Network Rail. I did notice as I was looking through the people on here that actually the gentleman from Network Rail, I don't know if his name's Darren Sharp. I think, is Darren still on the call? He's actually the project lead taking this forward. Darren, are you still on this call? Is he?
Here.
Yes, he is.
He is. Okay. So Darren probably would be able to tell you a lot more about the system, because it's not an Interflon system. It's a Network Rail system for lubricants, particularly to suit our product without having the solid in. But is Darren not? Is he not?
I'm there. I've been.
Oh, he's there. Here we go. I'll tell you a bit more.
I've been unmuted.
Darren should tell you a bit more.
No, hi, both Robs. So yeah, the auto lubrication system isn't just being designed for Interflon. It can be any other lubrication that happens to have the same viscosity. But the main aim is to reduce boots on ballast, so we don't have to go out to sites and have to manually lubricate switches. It's also used in very remote areas, so where we may have to go, say, once every 4 weeks to the Outer Hebrides, to somewhere very far away, where we can remotely adjust the levels of lubricant depending on the remote condition monitoring, depending on the environment, depending on the switch length. And every slide plate will have its own nozzle that lubricates onto it, and we can adjust the level depending on the environment and the switch type. So it's about to be retrialed, as Rob says. They did do a trial over 10 years ago, but it's moved on since then. I think the technology's moved on, the control units have moved on as well. So we've got remote condition monitoring for the pressure in the system, the amount of lubricant in the vessel, the temperatures, and so on. So it also tells you on the battery life and the power source as well. So for us, it's a good reduction of boots on ballast of staff. Safety of staff is a key thing for us. And the savings, we've demonstrated the savings are huge on people going to site having to lubricate switches. So yeah, still we will feed back any information and possibly do a paper and present on that in future if you'd like, to the UIEV on this. And also I know that the Permanent Way Institution are connecting in with you, Marco Aquati, trying to sort of develop our connections between the Permanent Way Institution and your side as well. So I'd be keen to sort of develop those links as well.
Okay. Thank you very much, Darren.
Thank you.
Thank you for connecting. Okay, very interesting to know. And a question also for you, Robert. You mentioned the long life of the roller. How long does the roller work on the switch?
A good question. As I mentioned, 5 years warranty, but our experience is up to the lifetime of the full turnout. It's, we have rollers, they are in use for 20 years. That sounds unrealistic and strange, but that's the truth. If you come to Vienna, in certain places you see rollers, and we are asked for spare parts and we say, sorry, they are now in use for 20 years. We don't have the spare part of this, but really, of course, it depends also a little bit. If you have extreme conditions with in the chemical industry and such things, then it's not on that level. But in general, our goal is same life, like the full turnout.
Okay, and you mean turnouts that are on highly trafficated lines, not turnouts that are.
That's not a problem because there comes no load into the roller.
Okay.
It's always just the weight of the switch blade.
Yeah. I didn't do the question right. I mean on switches that work a lot.
We don't care. We have a test facility and we make millions of operations. I know test facility are different to real life, and I can promise a lot of things. And by the way, I want to mention, if there is an interested potential client, we are open for a free trial to show if it really works like this. But back to the test facility, we tested for millions of operation, and I think last test was up to 30 years. Of course, what you cannot simulate is the environmental conditions. That's the problem, but the operation is not the problem.
Okay. Thank you very much, Robert. There are no any more questions. I look also in the Q&A. No, I think that we have done all. We have answered all the questions. So we are at the end of this talk. I hope that the participants have found it interesting. I want to thank again with the presenters. Thank you very much for your very deep insight in this very interesting topics. I appreciate it a lot. And I think, Charlotte, that the next 10th regulatory talk will be in 2-3 months. There's not a date, but as usual, we do a talk every 2-3 months.
Yeah, probably in June. Let's see. Let's see if we can do it before June or beginning of June. It depends also on the speakers. Yeah.
Okay. So thank you very much to all of you, and I wish you a good evening, and see you next time.
Thank you very much.
Bye-bye.